Hi, my name is Michael Ho, and this is my project on number syntax and learnability. Numbers are prevalent in society and are the backbone of the things we enjoy regularly: internet, buildings, cars, etc. Mathematical computations have driven technological advancement to new bounds, even to the moon. With the presence of many different natural languages, there are a lot of different number systems as well. Different number systems possess different lexical items, some with more number of words and less use of rules, and others with less number of words and more utilization of rules. Ultimately, all these number systems share a commonality: a base. A base is the point in which a number system incorporates its first rule and iterates upon itself. For example, Cantonese is a base 10 system and includes unique number words from 1 through 10, and the number 11 is the first instance in which a rule is introduced. It is built by the number 10 and the number 1 added together to make 11. If we were to manipulate an aspect of a number system, the base would be an apt aspect as it entails the amount of rote memorization and how much a rule is utilized. Say we have a base 4 versus a base 10 system. There are less words to memorize in the base 4 system, but the rule is also introduced earlier, which might make it harder to learn. We want to see if this has an effect on how learnable a number system is, and we are measuring learnability through accuracy and reaction time. The more errors a participant makes, the less learnable a number system is, and vice versa. So we had participants learn 6 spaces across 2 experiments. This is a between subjects design where a participant learned only 1 base. The first experiment had participants learn from bases 2, 3, 4, or 5, and the second experiment had participants learn bases 8 or 10. For each of the bases, the design was identical. Participants learned numbers 1 through 10 and were quizzed on the most recent number, but also ascending from 1 to the current number word, immediately after learning a new number word. After they finished the last quiz trial, they were shown a page with numbers 1 through 15 and were asked to fill in each of the blanks. The new material they were tested on was numbers 11 through 15, as they were not taught these numbers, so we wanted to see if they were able to generalize using the rules of the based system beyond which they were taught. Running a generalized linear mixed effect model to analyze the accuracy and a linear mixed effects model to analyze response time, none of our results were significant, unfortunately, but interestingly, in our generalization trial, our post hoc analyses showed a significant effect of both of our measures between base 4 and 8. These results contrast with the developmental literature, which did find correlative effects, as no significant effect was found from our testing using a novel number system. Base did not have any effect on either of our measures, which is interesting as it is the point in which new rules are introduced. Our data suggests that there is no effect of base on how learnable a number system is. However, as a generalization analysis between the base 4 and base 8 showed significant results, there could be another effect. In the generalizations, a multiplicative rule is introduced as 2 times 4 is required to compose the number 8. However, in base 8, there are no numbers tested that utilize this rule, this multiplicative rule, and base 8 performs significantly better than base 4. So, in sum, base 8 only used the additive rule, but base 4 had to use the both additive and a multiplicative rule to generalize the numbers. So, rules might be what makes a number system easier or harder to learn. The prevalence of rules could be the deciding factor of the difficulty of learning a number system. For the future, changes to design should be considered. A finding in developmental literature shows that children rely on sequence memorization early on in number word learning rather than actually understanding the value of the number word, so a randomization of sequence might be warranted. A different modality might also be warranted. The participants learned the novel number word in comparison to an Arabic numeral which is inherently base 10, so perhaps dots or dashes representing a quantity might be better used. Ultimately, seeing the significant results between base 4 and base 8 justifies more investigation into this, perhaps using different rules as a condition rather than bases. Thank you for listening to my presentation.